In this video, we will be talking about some function families, which are also called parent functions, and we will be talking about how to transform parent functions. So let's start with the quadratic. The parent function is y equals x squared. The graph is going to have the shape of a parabola, but let's plot some points to get us started. I'm going to use 0, -1, -2, +1, and +2. If you plug in 0 to this equation, you get 0, so I'm going to plot that point here. If you plug in 1, you get 1. If you plug in 2, you get 4. Over here, same thing, you get 1 and 4. And I'm going to connect these. Excuse my drawings, they're not the best. And we have our basic shape of our parent function for quadratic. The domain, remember, is the set of x values. So it looks like here I can plug in any x value and I'll get a real y value. So the domain is -infinity to +infinity. Remember, the range is from the bottom to the top, or the y values. So the range here, we can start at 0 and go to infinity. I put a bracket because 0 is included in the range. Okay, let's look at the absolute value graph. I'm going to use the points 0, -1, -2, +1, and +2. If I plug in 0, I get 0. 1, I get 1. 2, I get 2. -1, I get +1, and -2, I get +2. So I have 0, 1, -1, -2, and -2. And you notice the shape is similar to the quadratic, but this one is more exaggerated. It's actually more of a V shape. So let's talk about the domain. The domain here, I can plug in any real number and I will get a real number value back. The range is from bottom to top, so I would get from 0 to infinity. So these two are similar, but they do have slight differences that make them not the same function. Here we have a rational function. I'm going to use 0, -1, and 1 to help me out here. If I plug in 0, I'm going to get 1 over 0, and that is undefined. So I'm not going to have a point there. If I plug in 1, I get 1, and -1, I get -1. So I have this, and I have this. Well, what's happening is this is approaching here, and this is approaching here. So that is our basic graph, our parent graph for a rational function. So as you can see, the domain is not going to be all real numbers. But the domain is going to be from -infinity to 0, union 0 to +infinity. It can be any number except for 0. So the range, similarly, it looks like we can have any y value except 0. So again, it would be -infinity to 0, union 0 to infinity. Okay, we're looking at real numbers here. Here we have the square root function. I'm going to try -1, 0, 1, 2, and I'm going to skip down to 4. If I take the square root of a negative number, I'm going to get a complex number, and this one would be imaginary, so it's not going to show up on my graph. If I plug in 0, I get 0, 1, I get 1. Here I get the square root of 2, and the square root of 4 is 2. So I have 0, 0, 1, 1, and 4, 2. And that is our basic shape for our parent function of the square root family. The domain here is going to be from 0 to infinity, because all of the numbers over here will give us imaginary numbers. The range is the same. It's going to be from 0 to infinity. Alright, because remember, we're going from top to bottom. Here we have the exponential function. This is the most common one, so that's what I chose. I'm going to do -1, 0, and 1. So if I plug in 0, anything to the 0 power is 1. Here I would just get e, and here I would get 1 over e. So I'm going to plot these points. I have 0, 1, 1e is about 2 point something, and this will be about here. So there's our basic graph for an exponential function. The domain here, I can plug in anything, so the domain is from negative infinity to positive infinity, and the range is from 0 to positive infinity. Okay, so these are our parent graphs, and the reason we like our parent graphs is they give us the basic shape for every graph in their family. But we are going to do some transformations with these graphs, so we'll need to know what each transformation will do. So if you notice, I wrote each one in a similar form. They all have an A. The A value is going to shrink or stretch the graph. So it's going to be a shrink or a stretch. It will be a shrink if A is between 0 and 1. That will make the graph wider. If you shrink something, it's going to get wider. And a stretch is going to happen when A is greater than 1. Okay? If A is negative, we're going to reflect over the x-axis. Alright, so A does a lot of things. It'll either shrink or stretch the graph, or it could reflect it over the x-axis. H is going to move us left or right. So it's going to move us along the x-axis. We're going to go left if we have a positive number, and we're going to go right if we have a negative number. Okay, so what I would always tell you is it's going to be opposite with the x's. Okay, we have a k, that's going to move us up or down. If it's a positive, we're going to be going up. If it's negative, we're going to be going down. So what I would suggest that you do is that you practice doing some transformations of functions using a graphing calculator or an online graphing software, and just play around and figure out what transformations are doing all the time. Okay? One more thing that I want to share with you. If you have y equals and we'll just say negative x minus h squared plus k. If there's a negative in front of the x, that's going to reflect over the y-axis. Okay? So if there's a negative in front of everything, it's going to reflect over the x-axis. There's a negative just in front of the x, that's going to reflect us over the y-axis. So let's just review quickly. This value, reflect over the y-axis, the x-axis. If it's negative, it's either a shrink or a stretch, depending on how big A is. H is going to move us left or right. If it's a minus inside, we're going to go right. If it's a positive inside, we're going to go left. And the k value will move us up or down. So if it's a plus k, we're going to go up. If it's a minus k, we're going to go down. The only way to get better with transformations of functions is to practice them and practice them until you can see the graph without even graphing it on your paper.